Hi ladies, in this video we're going to go through this trig flowchart. So I've given you two. I gave you one that was not as detailed as this one here. And the reason for that is that's just a quick reference. But this one is a good way to revise what we've done in trig. And it's also good to keep. So you've got it on an A3 piece of paper. You can stick it up somewhere, maybe in a study space. Sometimes I would say to students, stick things on the back of your toilet door. So when you're sitting on the toilet, you can learn some maths, or on your shower screens when you're having a shower you can read it. It's up to you. So try to think about what you're going to do with this. Don't just put it in your folder never to see again, because with trigonometry there are a lot of formulas to use, and even though you'll have the formulas in your bound reference or on the formula sheet, you also need to know how to apply them. So this sheet kind of gives you a few examples. If I just scroll down, you can see there's space there for examples. I'm actually doing this video during period 4, your assembly time, and Mr. Dalton is doing a Teams meeting on either side of me. So I'm sorry if you can kind of hear that in the background, but I think it's not that loud. And the year 10s are being a little bit noisy, but we'll see how we go. All right, let's get started. So we're dealing just with triangles. I'm going to deal with the left-hand side first. So we're going to look at these right angle triangles. Okay, so remember a right angle triangle, we have a 90-degree angle. Okay, so here's a right angle triangle, usually denoted with a square there, but don't always assume if there's not a square that it's not a right angle triangle. Okay, sometimes you would have to prove that it's a right angle triangle. All right, when we're labeling our triangle, depending on where the angle is, so I'm going to put the angle here, and I'm going to call that theta. You can use X, or you can use any letter or symbol. This is a Greek letter, and we often use Greek letters in maths. Now, when you're filling or identifying your sides, look at your angle. Okay, the side with the angle, so I think A for angle, A for adjacent. So this is your adjacent side. The side opposite to your angle is the opposite side. And the side, or the longest side, or the side opposite your right angle is called your hypotenuse. I think I try to hide that. I think there might be an E or a U mixed up there. But O, A, and H we can use to identify the opposite. Oh, sorry. I was just making sure I was actually filming. That would have been funny if I wasn't filming. Okay, so identify your opposite, adjacent, and hypotenuse. You can call them O, A, and H. All right, so we use our trig ratios. I'm going to write the trig ratios down. So we've got sine theta equals opposite over hypotenuse, cos theta equals adjacent over hypotenuse, and tan theta equals opposite over adjacent. And that's where we get SOHCAHTOA from. So if you want to, you can write here SOHCAHTOA just to remind you. Okay, so sine opposite hypotenuse, cos adjacent hypotenuse, tan opposite adjacent, and they're just your trig ratios. All right, you can also use Pythagoras' theorem. So that isn't in this little box here, but just remember Pythagoras' theorem. And I'll put this up here, a squared plus b squared equals c squared. So we're going to look at that in a second anyway. All right, so let's scroll down. So finding a side. Okay, so in this side, in this triangle, our unknown side is here. Now, if we don't have an angle and we've got two sides, we're going to be using Pythagoras' theorem. So in this one, we know we've got, and I'm just going to put it here, when we've got two sides and we're finding the third side. So we're just finding the side here. We've got two sides, we're going to use Pythagoras. Okay, so two sides, we use Pythagoras' theorem, and I'm just going to scroll down and I'll do that example. Okay, so Pythagoras' theorem is a squared plus b squared equals c squared. Now, it doesn't matter what you label a or b, as long as c is always your hypotenuse. So if you want to label them a, b, and c, you can. All right, and then you just do your substitution. So we've got x squared plus 4 squared equals 9 squared. And then we're just rearranging to get x by itself. And then to get rid of the squared sign, we take the square root. Now notice what I've been doing, my working out. I haven't actually put the numbers in. I could do 81 minus 16 if I wanted to, but you need to show as much working out as you can. And that working, what I've done is sufficient. You've actually shown, you know, the working from going from x squared to x. You've identified the two sides under the square root sign. So now you can just do the square root of 65. And if we were to do that to 2 decimal places, it's x equals 8.06. And I just realized I need to keep space for the next question. So I'm just going to put a line there, and I probably should have told you to do that beforehand. Anyway, all right, let's have a look at the next example. So for this next example, we've got a side here. Our unknown side is x, and we've got an angle. So we've got one side and one angle. I think Mr. Dalton might be giving out awards or something, or maybe the Endeavour and what are they? Endeavour and it's raining too. What's the other award? SOHCAHTOA Excellence Award. That's it. Okay, so we've got one side or one angle, we're going to use SOHCAHTOA, so our trig ratios. Label your triangle. So the side with your angle is A, the side opposite your angle is O, and the longest side, or the side opposite your right angle, is your hypotenuse. So for this one here, we're going to be using the opposite and the hypotenuse because there's nothing there for A. So we use a trig ratio that has O and H, which is sine. So I'm going to scroll down and do that. Just find my pen. So sine theta equals opposite over hypotenuse. I'm writing a bit smaller this time. Okay, so sine, our angle is 58. Our opposite side is what we want, x, and our hypotenuse is 5. Now, don't go using solve in your calculator. You need to actually transpose this equation to get x by itself. So to get rid of 5 in this denominator, we multiply both sides by 5. So it's going to be 5 times sine 58 equals x. And then you can put that into your calculator. So x is equal to 4.24 degrees. Okay, so gives a bit of space there. All right, the next example, we've got an unknown angle. So we've got now two sides. Okay, and I should probably show this is finding a side, and this one's finding an angle. So we've got two sides this time, and we want to know the angle. So we're going to use SOHCAHTOA again. All right, so labeling your triangle. So we've got the angle here. So A, adjacent side with the angle. So A and A. The side opposite your angle is O. And then we've got the right angle. So the side opposite your right angle is your hypotenuse. Okay, so the values we have are O and A. So I'm going to use tan. So I'll just write the tan ratio. So tan theta equals O over A. So tan theta, opposite is 3, your adjacent side is 5. Now when you want to get theta by itself, you take inverse tan of both sides. And then you get your angle. So your angle for that one is 30.96, blah, blah, blah. So if I was to round that maybe to 1 decimal place, I would get 31 degrees. But notice my working out, girls. Put your working out clearly as I'm doing. All right, so there's your right angle triangles, remember, with a 90 degrees. Okay, so let's look at non-right angles, so not 90 degrees. Okay, and there's one here. When you're labeling your triangles, we use capital letters for our angles. So A, B, and C. And then the sides directly opposite. So this is angle A, and then we use lowercase a to do the side opposite it. Then we've got B and lowercase b, and C and lowercase c. So with non-right angle triangles, we can use the sine rule. Can you hear Mr. Dalton now? Or the rain, oh my gosh, the rain. So the sine rule, we have, and I'll see if I can write really small, A over sine A equals B over sine B equals C over sine C. And you only need two of these. You don't have to write all three. So once you have identified what you have, you just choose the correct ones that you need. So if you've got side A and you want angle A, but you've been given angle B and side B, you would use A and B. Okay, so labeling your triangle is extremely important. Now, if you wanted to, so these ones, the first ones are for the sides. So if you wanted to find your sides, if you wanted to find the angles, we can just flip them. So it doesn't really matter how you write them, but you will see them twice. So it just depends on whether you want to find your side or your angle. Okay, so there's your sine rule. Now your cosine rule. Okay, is a squared equals b squared plus c squared minus bc cos a. And obviously your a, b, and c are interchangeable. Okay, so it just depends on how you write your or label your triangle. So, you know, if you had b squared, you were finding that out, you would use your angle B here. So just remember the letter A, and A sticks with the angle. If you're finding B, you use the angle B. If you're finding side C, you'd use angle C. All right, so you can also use the cosine rule to find an angle. So if you're looking for angle A, you'd write cos A, and it's the same formula, girls, it's just been transposed, plus C squared minus A squared. I'm just copying from a piece of paper, so that's why I keep pausing, over 2bc. So 2 times b times c. When you put this in your calculator, just make sure you use brackets, please. Okay, so brackets extremely important. All right, so first up, if we're finding a side, so you can see here we're finding a side for this one, and this one. Okay, so we'll do those 3 examples first. I might actually make this bigger, so when I write, it's a bit easier to fit everything in. Okay, so this first triangle, so we're going to write it in this oval here. Think about what you have. So we have 2 sides, we want a side, and we've been given an angle. So we've got 2 sides and 1 angle. So that means we're going to be using the sine rule. All right, so let's label our triangle first. So it's already been labeled A, B, and C. I'll just scroll up a little bit. So the side opposite A is little a, side opposite B is little b, and the side opposite C is little c. So we're going to be using, we want to find this length here at C. Oh, just give me 1 second. All right, I just had to check because we're using the sine rule twice to do this one. Okay, so first of all, because we need to find this side here at C, we kind of need to find this angle here. Okay, so Sorry girls, I just got a bit distracted. So we do need to find this angle here, but we can't use the sine rule to find that, but I can use the sine rule to find this angle here at A. So I'm going to find A first. So I'm going to write my formula. So sine A equals, now because I've got the angle B, I'm going to use sine B. So it's sine A, sorry, I should have written the rest of it. Sine A over A, sine B over B. All right, let's keep going. So sine A, that's what we're looking for. Lowercase a is 6. Sine B is 37, sine 37, and lowercase b is 4. Now, if we're finding A, we just got to, first of all, multiply both sides by 6. So we're going to have sine A equals 6 sine 37 over 4. And then we need to take inverse sine of that. So 6 sine 37 over 4. So your angle at A is 64.518. I think I'm reading that right. So if A is 64.518 and B we worked out, we know is 37, that makes C, because all your angles inside a triangle add up to 180. So that means we're left with C equals 78.48. Okay, I'm actually copying someone else's working out. I'm not doing them as I go, so I'm hoping they're correct. All right, so we've got angle C now, and I'm running out of room, which is really annoying because I'm not going to be able to fit everything in. Okay, so now we want to find lowercase c. Okay, so remember, let's just go back up to the triangle. We're finding C here. So we're going to have C over sine C. And it's probably better to use what you already have. Don't use A, so we're going to use B. So sine B. So C over sine 78.48 is equal to B, which is 4 over sine 37. And just because we're running out of room, I'm going to do the length of C, which we labeled as X. I'm going to call that X, sorry. X is 6.51. Now Mrs. Brennan's talking. All right, so there's that question. So quite a bit of work there, but you'll get there if you just label your triangle properly and take your time. Okay, I'm going to, just because we're a bit close in working out, I'm going to change my pen to purple. All right, and now we're going to look at this triangle here. So the first thing we need to do is label it. So the side opposite A is A, then we've got B, and then C. They've already been labeled A, B, and C, but if they weren't, you just go ahead and label them. So this time we've got two sides and an included angle. So included angle. And what it means by included angle is that the angle that is known has the two sides either side known as well, whereas this one didn't. Okay, so it didn't have an included angle because we didn't know this side here at C, but here the two sides adjacent to the angle we know, so we call that an included angle, and it just means that we can use the cosine rule. Okay, so I'll write down the cosine rule. All right, so I've labeled them. We're trying to work out C. So I'm going to write C as what we're working out. You'll notice in our original formula, it said A. And as I said before, you just interchange them depending on what you need to know. So we're going to have C squared equals B squared plus A squared minus 2BA cos C. I guess if you didn't know, oh gosh, what am I doing? Let me just rub that out. I was just thinking, if you didn't know maths too well, you'd probably read that as Bakosk. But anyway, it's 2 times B times A cos C. And if you want to put the multiplication in there so you don't read it as Bakosk, you can if you like. All right, let's do our substitution. So don't, oh gosh, sorry. I had the, oh, go away. I had my eraser still on. Okay, so don't just write the formula and then the answer. You actually got to do the substitution. So we're going to have 4 squared plus 5 squared. Again, I'm just getting these values off the triangle. Minus 2 times 4 times A. And it doesn't matter what order you put B or A in. And then cos 53. Oh, 2 times, sorry, I'm getting confused. There we go. Miss Brennan talking is confusing me. Cos 53. Not that I can understand what she's saying. Okay, so you can then do the square root of all that. And I would say leave it all like that. Don't go putting it in your calculator and then rounding it. Okay, there we go. So when you put that into your calculator, you should get 4.11. Okay, so that's the value of x there. Oh, I should write, sorry, that is x, not c. I probably should have put x there and x here. Okay, so that's the cosine rule for the second one. Let's go to the third example. So let's do this one in green just because we've got a little bit, got to separate it. There we go. Okay, so it's getting a bit messy, but it's all good. Hopefully you've got small handwriting and you're actually writing with a pen, not on the computer screen. Okay, so the third one, we have at the moment, we've got 2 angles and 1 side. But if we've got 2 angles, we can easily work out the third angle because remember all your angles inside a triangle add up to 180. So this angle here is actually 85. Okay, so that might help. So if you need to put that information in, you can. All right, and let's label our triangle. So we've got A here, so I'm going to put a little a here, B, and C isn't on here, so let's put it on, and then C. We don't really need to use C, maybe that's, oh no, there's angle C. Okay, so we're going to use the sine rule. And because we know, or we want to know B, lowercase b, so I'm going to use lowercase b and the angle at B, and I know A and the angle at A. So I'm going to use B and A in my sine rule. So where am I going to write it? Let's write it down here. So B over sine B equals A over sine A. And then just substitute in your values. So I should have always put in x for the unknown, but I hadn't been. X over sine 85. And then lowercase a is 6. And then sine 40. Okay, so uppercase A is 40. And then to get x on its own, we just multiply both sides by sine 85. So we're going to have 6 times sine 85 over sine 40. And then x is equal to approximately 9.3. Okay, so let's close that one off. So that's that example there. All right, now we're going to find the angle. All right, so I'm going to go back to pink because I just finished with green. Okay, so let's look at our first triangle. Okay, so we've got 3 examples here, 1, 2, and 3. Here's our angle, it's labeled angle C, so let's call this side here C, A, and then B and B. Okay, we don't probably need A, but let's write in here what we have. So we have two sides and one angle. Okay, so our two sides are C and B and our angle is B, and we're going to use the sine rule. Okay, so we're working out angle. Let me just scroll up a bit. All right, so we're looking for C. Sorry, I keep getting distracted. You know, my biggest fear, because my recording screen keeps going off and I kind of feel like I might be talking and it hasn't recorded anything, but instead of checking, I'm going to keep going. So if you're hearing this, you know it worked. Okay, so sine X, because C is our unknown, over C, which is 5. And then sine B, big B, 30 over little b, which is 3. And then just to show a little bit of working out, we need to multiply both sides by 5. So sine X equals 5 sine 30 over 3. And then we're going to take inverse sine. Sorry, I'm just getting distracted again. Oh, I was wondering when we found the angle before. We did that here. Okay. I was just thinking we've already done this, but that was because we had to do two methods here. All right, so X is equal to inverse sine of 5 sine 30 over 3. And then we just put all that into the calculator. And I need to check my working out. Let me just make sure I'm in the right spot. All right, so our value of X is 56.4 degrees. Now, as this triangle is drawn, you can see that it is an acute angle, that it is less than 90 degrees, but you should be aware that this could also be the ambiguous case of the sine rule. So I want to show you here how that works. So if I redrew this triangle down here, okay, so if it wasn't drawn and this side was 3, so it would be an isosceles triangle, two sides are the same. That means we would be working out this angle here. Okay, so you need to be aware that you're not all, and if that was C, I'll call that C dash, there may be two solutions to your triangle. So that's what the ambiguous case of the sine rule is. It's when this side here could be 3, but you could also bring it in here, and that would give you that angle. Okay, so it's an obtuse angle. Now, because these two sides are the same, you're going to get the same angle here, X. And that's why when we do the ambiguous case of the sine rule, we have this angle here, our acute one, but we have this angle here, our obtuse one, is just 180 minus X. Okay, so once you've found your acute angle, to find your other, oh gosh, hopefully if I start writing it disappears. Your other angle could be 180 minus 56.4, which is 123.6. Okay, so two solutions, and that's because you could have this side here B. I know this triangle here has drawn it as an acute angle, but you need to know that the sine rule can sometimes give you two solutions, and that's because if this side here is 3, we can redraw the triangle, and this could be 3, so it becomes an isosceles triangle. That makes these two angles the same, so that angle at your new C is 180 minus X. All right, so the next example I'll do in purple. Okay, and I've got about 8 minutes and then I have to go to yard duty. Okay, so this one here, and I think I may have got this mixed up. Anyway, let's just keep moving on. So this one here, we've got 2 sides and an included angle. Okay, so we know these 2 sides and we know the angle in between. So included angle. Label your triangle, so A and little a, B and little b, C and little c. So we're going to use the cosine rule. And then we also have to use the sine rule. Okay, so we can't just use the cosine rule. We need to use the cosine rule and the sine rule. All right, let's just give us a bit of space. Okay, so the first thing we're going to find is we need to find this length here. Okay, and then we can find x. Or you could find this angle here. Okay, so you could have used find A. So we could either use the C's or the A's to find our B's. So I'm just going to be, stick to what I've got in front of me. So I'm going to do C. So we're using the cosine rule. Okay, so your cosine rule, it should be C squared equals B squared plus A squared minus 2 BA cos C. Now, just because I don't have much room, you can just substitute everything in. So don't be lazy. We're going to have, we're going to have C squared equals 8 squared plus 6 squared minus 2 times 8 times 6 cos 35. All right, and then remember you take the square root of both sides to get C. So C is going to be 4.62. Okay, so now we've got this length here, and then you can use the sine rule. So we're finding out angle B, so we're going to use sine capital B over lowercase b. We worked out C before, so I'm going to do sine C over little c. So substitute them in. Oh, I really don't have much room for the next question. So sine x over little b, which is 8, equals sine 35. Now, I have done the working out for something similar over here. So if you've got space on your page, please show the working out. I'm just going to give you the final answer, which is x equals 83.1. But I hope that you would have enough space on your sheet to write that in. All right, let's go to the last example. So I've got 5 minutes before lunchtime. Okay, so I'm going to do it in green. So this time we've got 3 sides and we need to find the angle. So I'm going to write here what happens when we've got 3 sides. So I'm going to label them A, B, and C. So side with A, then we've got B, and then we've got little c. All right, so I'm going to use the cosine rule. Now, do note, because we are looking for an angle, I'm going to be using this formula here. You can use the first one. It just means you have to transpose it. So it's probably easier to do it when it's already transposed for you. Now, I might write it in this space here. Obviously, I don't have much space, but so we're going to find, what are we looking for? Cos A. And I'm just going to copy it straight from up there. So B squared plus C, minus A squared. I'm sorry, don't have much space. 2BC. All right, so substitute all your values in. So I'm going to do that substitution, but I would like you to then go away and do everything on your own. So plus 6 squared minus 8 squared over 2 times 4 times 6. Now, if you're doing this in your calculator, make sure you use brackets. And then when you're getting x on its own, you're going to use inverse cos of all this. So that will all go in brackets. Okay, so this just goes here. All right, I'm not going to rewrite that. And your answer is x equals 104 degrees. All right, so a lot of work, girls. I'm happy you stuck by me and you didn't hopefully just fast forward to the end. Okay, if you did, I'm going to scroll out just to be kind, but it is a bit messy. Oh, okay, so you can kind of see there, and I'll scroll down in a second. All right, so not the neatest, but hopefully yours is. All right, bye, girls.